All right, you guys. So today's lesson is going to be very visual. So it's going to be kind of tough, but I think we can power through it together. um, I also want to let you know the assignment that is posted with this today. We're going to do a couple of the questions together. I believe 9 or 10 of them we do together. Uh, so even though the assignment itself looks like it's a lot of questions, I hope you know that number one, if you need extension on it because you're still trying to figure it out or you have questions or you couldn't make it to office hours, whatever that is, just email me, let me know, and I'll walk you through it. But also please know that the purpose of the assignment is to give you as much practice as possible. Okay, I don't want you to overload yourself or spend 2 hours doing the homework assignment because of how many problems there are. My hope is that once we go over how these questions work, you might start out kind of slow for the first few questions, and then you will slowly kind of speed up your ability to answer these questions more quickly, is kind of the goal for this. Okay. So hopefully in front of you, you have your unit circle. I have a picture of my unit circle as well for my reference, okay? So what I'm gonna show you guys is what we need to use this unit circle for. So before we can do that though, we need to add a few things to our unit circle, okay? So here are our 6 trig functions, right? Sine, cosine, tangent, cosecant, secant, and cotangent. So the first thing we need to do is on your unit circle somewhere, you need to add those 6 trig functions, and you're going to make 3 columns, okay? The first column is going to be how we describe these ratios using geometry. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So then when we introduced cosecant, we said, well, cosecant and sine kind of go together. So if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. Same thing with cosine and secant, how they go together, and tangent and cotangent, and how they're opposites of each other, okay? If you want to label that like I have, where you have them kind of color-coded going together, you absolutely can do that. The next column you should have written down is the trig version. So this basically means if you're looking at the circle in front of you, okay? If I look at sine is opposite over hypotenuse, for example, okay? Well, if I'm looking at sine of this guy, okay? If sine is opposite over hypotenuse, well, the opposite is your height, which is like your y value, and your hypotenuse is the radius of that circle. So if you look back at this next page, I have written out y over r. Okay, that's where those numbers come from. If you look at cosine of something is adjacent over hypotenuse. Well, adjacent is the x value, hypotenuse is the r. So you'll see how I've written x over r. Okay, so that's where those trig, kind of the trig version comes from. The next thing we're going to talk about is strictly for the unit circle. If that truly is a unit circle, the radius of this circle is 1 because it is a unit circle, so 1 unit of something, right? So if I take all of those y over r, x over r, and so on, and I replace every r with 1, okay, that is where the unit circle comes into play. So what that means is, okay, these bottom 4 right here don't change too much. Okay, they kind of adjust a little bit, but nothing too crazy. Versus look at these guys. We would never leave something as a number over 1, right? We would simplify it. So if you go to this next section right here, sine of theta is just the y value. Cosine of theta is just the x value. This is going to come into play with what I'm going to call special cases at the end of this video. So underneath this, if you could please write cosine, comma, sine, because cosine of theta is equal to x, sine of theta is equal to y. So if you could write that down for me, we'll reference back to that here in just a second. The next thing I want you to do on your unit circle, so this, for example, this whole slide should be written maybe on the back of your unit circle. If you have room on the front, awesome, but my guess is you probably don't. So if you want to put this on the back, that would be best. The last thing I want you to add is all the trig relationships. Again, I recommend the back of your unit circle if you can. So for example, the fact that sine of theta is the opposite of cosecant and cosecant is the opposite of sine, okay, right? They're almost like inverses of each other. Same thing with cosine and secant. And then same thing with tangent and cotangent, okay? The last thing I want you to add that's a little bit different that we have not yet talked about yet. Tangent of theta can also be a slightly different ratio. Tangent is also actually the same thing as sine over cosine. That's not something we have talked about yet. There is a reasoning for that, but it's kind of hard to explain just through a video. So just trust me for now. Those of you guys that are going to pre-calc, Mr. Miko will walk you through kind of the reasoning by hand. But for that, for the rest of you guys, just make sure you have it written somewhere. So that must mean if tangent of theta is sine over cosine, cotangent is cosine over sine. So those are kind of the two special ones that I want you to have written down. All right, so here's how this works. Okay, what's going to happen is I'm going to give you problems just like this. Find the ratio for cosine of 2 pi over 3, okay? What you're going to have to do is use the unit circle to help you with that, okay? So I'm going to use my highlighter as much as I can. So here I'm going to erase all that highlighter stuff I've got here. And let's do this first question together. So the handout, the homework assignment that's attached with this, these are all directly from the homework assignment. So any question we do together on the video, you can say, awesome, I've already got that one done. Mrs. Nurs helped me, okay? So let's look at the first one. The first one is cosine of 2 pi over 3. So here's how this works. I go back to my unit circle and I find 2 pi over 3. That means I'm looking at this orange triangle that goes with 2 pi over 3, okay? It's asking for cosine of 2 pi over 3. Well, cosine is adjacent over hypotenuse. So the adjacent, so we're looking at this angle as your reference angle. Adjacent is this line. Hypotenuse is this one. So if I go down here and I reference this triangle, that means my adjacent line is square root of 3, and my hypotenuse is 2. So I'm going to write next to this guy equals square root of 3 over 2. When I go to slide out the answers, okay, now wait a second, that's not what I got. The answer should be negative 1 over 2, right? So let's go back, let's see what I messed up here. Cosine of 2 pi over 3. Cosine is adjacent over hypotenuse. Oh, I did opposite over hypotenuse, that's why. So let's erase this guy, that's why I screwed that up, I'm sorry. All right, so I want adjacent over hypotenuse. Some of you guys were probably yelling at me watching this video, Mrs. Nars, you're doing it wrong. So adjacent over hypotenuse, so that means I want 1 over 2. But notice how the answer is negative 1 over 2. Here's why this works. When I'm doing this right here, do you see I'm going left on the x-axis? That means I'm going negative 1. That distance, even though the distance is 1, since I'm going to the left, it's negative 1. So that's why the ratio is negative 1 over positive 2, and then that's where that number comes from, okay? Sorry about screwing it up the first time, that was my bad. Let's do another one. Let's see if I can redeem myself here. So sine of 3 pi over 4, okay? So now I'm going to start fresh again, okay? Sine of 3 pi over 4. I'm going to look at 3 pi over 4, which is right here. So I'm looking at this blue triangle over here in quadrant 2. And if I want sine, I want opposite over hypotenuse. So if this is my reference angle, I want opposite over hypotenuse. Well, the opposite side is 1, and the hypotenuse is square root of 2. So in my answer, I would take my pen, and I would write equals 1 over square root of 2. But remember how we said we can't have square root of 2 on the bottom? So I need to rationalize the denominator by multiplying by root 2 over root 2 and make it square root of 2 over 2 for my final answer. You'll notice, let's see if I can redeem myself. Yay, okay, I got that one right. I didn't screw it up like I did the first one. So you get square root of 2 over 2 for that guy. Okay, let's do another one. Tangent of 2 pi over 3. So again, I'm going to erase. The only reason I'm highlighting on my unit circle, you guys, is you can see what I'm doing because it's kind of a visual concept. So tangent of 2 pi over 3, I'm looking at 2 pi over 3, so I'm looking at this orange triangle in quadrant 2 again. Tangent, if this is my reference angle, tangent is opposite over adjacent. So the opposite side is square root of 3, adjacent is 1, but notice how this adjacent side is going to the left. That means it's going to be square root of 3 over negative 1. So if I take my pen, I would write equals square root of 3 over negative 1, or just negative square root of 3 if I simplify. Let's see, how'd I do? Yay, okay. Doing much better now. All right, let's do a couple more, and then you guys are going to work on half of your worksheet today, and then we'll do the rest of them tomorrow, okay? So let's just do a couple more. Cosine of negative 5 pi over 6. Okay, so this is a little goofy. It's negative, right? Remember how we talked about positive degrees versus negative? Positive goes counterclockwise, Okay, negative goes clockwise. So here's what that means. When I go to look at my unit circle, you might think we just go to look at 5 pi over 6. Not the case, right? 5 pi over 6 is right here. But that's if my angle measurement was positive. So what I need to do is say, okay, if 5 pi over 6 is from here to here, then negative 5 pi over 6 is from here to that same exact spot right over here. So negative 5 pi over 6 is actually the same thing as the 7 pi over 6. So that's what I'm going to be focusing on. Okay. So now it said, what was the question? Cosine of negative 5 pi over 6. So cosine, I'm using this guy as my reference angle. Cosine is adjacent over hypotenuse. So adjacent is this side over hypotenuse. Well, the adjacent is a negative value, right, because we're going left on the x-axis. So that's going to be a negative square root of 3 over 2. So if I go to write that, I should get equals negative square root of 3 over 2. I don't need to rationalize or do anything with my answer. And that's the answer I got as well. Let's try another one. Tangent of negative pi over 6. Okay, let me erase all this. All right. Tangent negative pi over 6. Well, pi over 6 is right here, right? So negative pi over 6, I'm going to be looking at this angle right here because you're going in a different direction, okay? So that means I'm looking at this guy as my reference angle. I wanted tangent. So tangent is opposite over adjacent. So opposite over adjacent. Well, the opposite side, that is a 1, but notice how I'm going downwards. That means we're going to use negative 1. And the adjacent side is square root of 3, but it's positive because I'm going to the right. So negative 1 over square root of 3 should be my answer for this one. So negative 1 over square root of 3. I don't like that, though. I need to rationalize the denominator. So I actually want negative square root of 3 over 3 for my final answer. Let's see how I did. Yay, okay. I'm not making any more mistakes, so that's good. All right, last one, you guys. Sine of 5 pi over 6. Go back to our unit circle. It's just regular positive 5 pi over 6, so I know I'm just going to look at this guy right here. I don't have to do the whole negative thing. So if this is my reference angle, and I want sine, sine is opposite over hypotenuse. So that means my opposite side is 1, my hypotenuse is 2. So this answer should be a nice straightforward 1/2. Let's see how I did. There we go. Awesome. So here's the deal, you guys. What I want you to do is work on some of the handout that I gave you. This handout will not be due until tomorrow at midnight. As of right now, you can do any questions that are sine, cosine, and tangent, okay? If you see any questions that look like, for example, this slide, so anything that's cosecant, secant, things like that, you might not be able to do those. Also, if you get to questions that are things like sine, cosine, or tangent, but they're asking you to do it for either 0, 90, 180, or 270, any of these lines, go ahead and skip those ones as well because those are special cases that I will show you guys how to do in the video tomorrow, okay? But you can do all the questions that are sine, cosine, and tangent, whether it's positive or negative, okay? Just skip the ones that ask for 2 pi, pi over 2, pi, or 3 pi over 2, okay? We'll finish the rest of this tomorrow. Remember, stop by for office hours if you're getting stuck so I can try to help more, okay?